Hi everyone, I hope you're well and I hope the lockdown is treating you well and that you're not too frustrated in the house because I am really frustrated and I can't wait for school to start just to get out. But anyway, okay, lesson 4. We are still busy with reduction formulas, so this is reduction formulas continued. Okay, there will only be one video today, so that's nice. Okay, so just to recap cast again, guys. Remember now, this is the first, second, third, and fourth quadrant. Cos is sin, cos, and tan positive in the first quadrant. Sine is positive in the second one. In the third one, tan is positive. And in the fourth quadrant, cos is positive and all the rest are negative. Okay. And then I also drew you this little thing as a summary. So draw this in your books as well. So we work with 90 minus theta in the first quadrant. In the second quadrant, we work with these two reduction formulas. In this quadrant, we work with 180 degrees plus theta and 360 minus theta. It's easy to also remember because the 90 degrees is here. So obviously that will fall in there. This is the 180 degree line. So anything, or 180 degrees minus anything will fall here. Plus anything will fall into this quadrant. And this is this 360 line. So it's also a little bit common sense. Okay. So I'm going to explain to you how we are going to apply the reduction formulas. And how you could be asked to do it. So this is one way of asking it, is to simplify the following. Okay. So for us to cancel out in division, obviously we need sine at the bottom or cos at the top so that we can cancel out and simplify this, because like this, we cannot do anything with it. We can't simplify it. So we're going to do it one by one. Sine 360 minus theta falls in that quadrant. And in the fourth quadrant, sine is negative because only cos is negative. So this one is going to be sine theta negative. Negative sine theta. Do you see? Because in that reduction formula, sine stays sine, but it is a negative because it's in the fourth quadrant. Okay, then this one, 90 plus theta, falls into that quadrant in the second one. So we can already see there that sine is positive. But when we work with 90 degrees, guys, remember sine will change to cos. And sine in that quadrant is positive, so it's positive cos theta. Okay, at the bottom of the line, this one falls into that quadrant. And sine, cos, and tan is positive in that quadrant. When we work with 90 degrees, cos changes to sine, and it's positive because it's in the first quadrant. This one falls into the fourth quadrant, where cos is positive. And when we use the 360 degree angle, in the reduction formulas, cos stays the same. And we only have to change the positive to a negative or negative to a positive depending in which quadrant it falls, but over here cos stays positive. And now we can actually simplify it. That and that cancels, sine and sine cancels, and we're left with minus 1. So that's the answer. Okay, then the second way they can ask you this is to write the following as a function value of an acute angle, or as function values of acute angles. Now remember, first of all, guys, acute angles are smaller than 90 degrees. Now that's bigger. Oh my goodness. Like that. Smaller than 90 degrees. Okay. So then they give us sine of 290 degrees. So guys, sine of 290 degrees is bigger than 90. So that is not an acute angle. And they are asking us to write it as an angle smaller than 90 degrees. So let's first on this Cartesian plane indicate where this is going to fall. So there's 270, there's 180. So we can already see that 290 will fall in the fourth quadrant between 270 and 360. And in this quadrant we work with 360 minus theta. So we're going to say 360 degrees minus. Now, what do we have to subtract from 360 to get to 90? 70 degrees. Okay, so that is the same as that. And our rule says that any degree or any, when sine of 360 minus any angle will be the same as sine of that angle, okay? Except we have to keep in mind, will it be positive or negative? Now in the fourth quadrant, only cos is negative. So it's going to be negative sine 70. Okay, do you see guys, it's actually not that hard to apply this work. Okay, tan 197. Guys, so 197 is going to fall in this quadrant, okay, because it's between 180 and 270. And when we work in the third quadrant, over here we work with 180 plus theta. So we're going to say 180 plus whatever angle we have to add to this to get 180. No, what we add to 180 to get to this. Now we have to add 17 degrees to get to 197. Okay, and our rule says that tan of 180 degrees plus any angle will be the same as tan of this angle. Okay, except for the positive and the negative, which you have to make sure of. And in the third quadrant, tan is positive, so it's positive. Okay, then the last one, cos of 120. 120 will lie somewhere here between 180 and 90. And in that, the second quadrant, we work with 180 minus theta. So we say 180 minus, what will we have to subtract from 180 to get 120? 60. Nay. Yes. Okay. And again, guys, our rule says cos of 180 degrees minus any angle will be the same as cos of that angle. Okay. Now let's just make sure whether it is a positive or a negative. In the second quadrant, only sine is positive. So this is going to be negative cos of 60 degrees because cos is always negative in the second quadrant. Okay, here is your homework. Please do exercise 2 on page 144 only, question 2A, B and C, and exercise 3 on page 145, C, D, F, H and I. Please send it to me before tomorrow 10 or 11 o'clock again, guys. We are not going to do any work tomorrow because it is actually technically a public holiday. And remember, it's Easter weekend, so enjoy it and may you have a blessed weekend with your family. Take a little break from the online schooling. It's hard and it's tough, but I think you are doing good. Okay, enjoy your day, guys.